This is the protocol for extracting the EPS of periphyton biofilm using cation exchange resin. For the detailed methods and materials, please refer to the thesis. Weigh the amount of sample required using the VSS ratio determined from the previous protocol. Each sample will use 35 grams of cation exchange resin and should contain 0.5 grams of volatile suspended solids. Next, transfer the sample to a 15 ml Falcon tube and then add 5 milliliters of 0.1 times diluted PBS solution. This is the extraction solution for the rest of the procedure. Put the sample on an orbital shaker and set to 300 RPM for 1 hour at 4 degrees Celsius. Next, transfer the shaken samples to centrifuge tubes. Alternatively, you can shake the samples in centrifuge tubes beforehand to avoid a transfer. Next, centrifuge the sample at 1000 Gs for 20 minutes at 4 degrees Celsius. This will separate the colloidal EPS from the sample. After centrifugation, transfer the supernatant to a clean and labeled 15 ml Falcon tube, ensuring that no particulate matter is in the supernatant. This is the colloidal EPS. For each of the following steps, take the weight measurements before each step. To extract the bound EPS from the biofilm using cation exchange resin, begin by adding 35 grams of cation exchange resin to a 125 ml Erlenmeyer flask. Then add the sample from the previous centrifugation step, followed by an addition of 20 ml of 0.1 times PBS solution. Then add the samples to an orbital shaker set at 300 RPM for 4 hours at 4 degrees Celsius. After 4 hours, transfer the solution in the sample flask to a centrifuge tube, pipette off any extra, but do not get any cation exchange resin in the centrifuge tube. Lastly, transfer the centrifuge tubes and centrifuge at 1000 Gs for 30 minutes at 4 degrees Celsius. The final extract should appear as such. Transfer the supernatant into a 5 ml conical centrifuge tube, ensuring that no particulate matter is in the supernatant. This is the bound EPS and should be stored at -20 degrees Celsius for downstream analyses.